So from the last tutorial, you understand how we get the heat gained from the water, and also how to get the heat lost from the copper block. So now we apply the concept of the law of conservation of energy and put it into the equation. Now, one thing try to avoid is that we are not setting them equal to each other. What we are doing is making use of the equation based that we had previously, and we put in what we found out about the heat energy gained and the heat energy loss into the equation. So on the left hand side, you can see we put the heat energy gained by the water right here, okay? And on the right hand side, don't forget that there is a negative sign outside the heat energy loss. This is based on what we previously found out according to the law of conservation of energy. So keep that in mind, because this tends to be one of the most common mistakes, which is people forget to put the negative sign outside here. And if you do not put the negative sign, you will get the wrong answer. So this is what we do here. Now try to keep the unit, okay, with the numbers, because it will really help you out to prove whether or not you are on the right track. For those who do not write units, then you lose a very valuable tool to check for yourself, and by writing units, you know what is going on, you know what you're doing is right or not, okay? So now, we have to solve this equation. We only have one unknown and we have one equation. This should be very doable. It is the same concept that you learned in Algebra 1. However, one of the challenges that I have seen so far with the students is that, well, those numbers are not pretty numbers. And then the numbers are with the unit. So that kind of freaks students out. But think about it, it's just a number with a unit. It is just like any other number. You make sure you do every single procedure correctly. If you have parentheses and you have a number outside of parentheses, make sure you distribute the number correctly, okay? So, this is what we have here. So 92 joules per degree Celsius, we are going to distribute into the parentheses. So we have this number times TF. I'm going to use parentheses just to make sure that I know this is one entity. I'm not confusing with the unknown and the units. And then we have 92 times 20 degrees Celsius. Now the degree Celsius would be canceled out in this case. And then we have 41840 joules. Okay? So that's on the left-hand side. On the right-hand side, now let's try to keep the negative sign on the outside, because we would like to deal with the parentheses inside first. Okay? So no hurry of getting rid of the negative sign. So let's distribute this number into the parentheses. So that will become 77.0 joules over degree Celsius times TF minus 77 times 105, which is 8085 joules. Okay? And then now you can distribute the negative, and make sure you distribute the -1 into the parentheses very carefully. You will have this negative, it becomes positive. Okay? And on the left-hand side, since we did not do anything, we just write down everything as we have seen from the previous step. Okay, now, right at this step, we have some terms. And what we're going to do in the next step is that we're going to combine the like terms. And let me point out to you what are the like terms. Well, the easiest ones to spot out will be this one and this one. These two are the like terms. And this one and this one are the like terms. Now, how do you know? Well, they both have the known T of F, okay, with subscript F, the final temperature. They both have the same unit, and they are only different. They are only different by the number. So we can combine the like terms. Okay, so we move this here, that becomes positive. And then we move this term over here, so we have 8085 joules plus 41840 joules. Okay, and then we add them together. So we have 2169 joules per second, T of F. And on the right hand side, we have 49925 joules. And then you just isolate the final temperature by dividing this term on both sides. And you should get 23.02 degrees Celsius as your answer. Now the joules right here, they will get canceled out when you divide them, okay? And then the degrees Celsius will be flipped and goes on top. So this is how you finish the question one. A couple reminders. Everything up until here is all concept. If you do anything wrong right here, it should be the algebraic mistake. So make sure you go back and check if you make any careless mistakes. And on the other end, check the answer. See if it makes sense. If you did not do, if you have some error, the number right here, the final temperature or whatever answer you calculate, that may be some number which would make no sense to your question. So this will be a good checkpoint. So I hope you understand how to do a problem that involves heat exchange, heat transfer, and understand how to do those questions based on the law of conservation of energy.